Find the volume of the solid when the region bounded by y is equal to the square root of the quantity 4 minus x squared, x equals 0 and y equals 0 is rotated about the x-axis. Well, let's first sketch a graph to see what it's going to look like. So we have our graph here, and it's bounded by x equals 0 or the y-axis, so that's going to be one boundary, y equals 0 or the x-axis, and then this function. So let's actually try to convert this into a form that we may be used to from prior math courses. So I'm going to square both sides. If I do that, I'll get that y squared is equal to 4 minus x squared. And if I add x squared to both sides, I get x squared plus y squared is equal to 4. Oh, this is a circle. So a circle that's centered at 0, 0 and has a radius of 2. Okay, so we have something like this, and I could continue going around to show the full circle, but the thing is that our region is bounded by the y-axis and the x-axis. So it's basically this area here, and then we're going to rotate it about the x-axis. So it's going to go around and kind of look like this. So it looks like half of a circle, or half of a sphere, I should say, half of a sphere. So now that we know what this graph looks like, we can set up the integral that we are going to use. So we're going to have the integral, and we have pi out in front of it, from 0 to 2 of our function. Because we're rotating it about the x-axis, we want it in terms of x. So we want the square root of 4 minus x squared, because that's our radius, and we're going to square that, and we're going to integrate it with respect to x. Well, when we square the radius, which is a square root, the square root and square cancel each other out. So we can rewrite this as pi times the integral from 0 to 2 of 4 minus x squared dx. Okay, now let's integrate. So when we integrate, we still have the pi out in front, and then we have 4x minus x to the third over 3. And we're going to evaluate that from 0 to 2. So we'll still have pi out in front, and we'll have 8, which is 24 thirds, minus 2 to the third is 8 thirds, and then minus, if we substitute 0 into both of these terms, we end up getting 0. So we have 24 thirds minus 8 thirds, which is 16 thirds, and then if you multiply that by pi, you'll get 16 pi over 3, or answer choice C. Now, it was noted when we first drew and visualized the solid of revolution here that it's going to be half of a sphere or a hemisphere. And if we remember, the volume of a hemisphere from geometry is equal to 2/3 times pi times the radius cubed. And it's 2/3 instead of 4/3 because it's half of 4/3. So if we substitute our radius of 2 in there, we have 2/3 pi times 2 to the third. We get 8 times 2, which is 16 pi over 3. So notice we get the same exact answer, whether we use the integral or the volume formula for a sphere, since it ended up being equivalent to that, or the volume formula of a hemisphere. So that's answer choice C.